Yes, dear student, there is a question on the board. There are only 5 molecules per cubic centimeter in region of space where temperature is 3 Kelvin. What will be the pressure of such a fluid gas? Kb means Boltzmann constant 1.38 10 to the power minus 23 joule per Kelvin. Just now in last video I gave you a summary of the gas laws, and we know Pb is equal to K x kBt. What is x? Total number of molecules in a given volume. So we want pressure here x upon v kBt. X is 5, v is 1 centimeter cube. 1 centimeter cube is equal to 10 to the power minus 6 meter cube. You know why it is so? 1 cubic centimeter. 1 cubic centimeter means 1 centimeter into 1 centimeter into 1 centimeter. 1 centimeter 10 to the power minus 2 meter, 10 to the power minus 2 meter, 10 to the power minus 2 meter. So meter into meter, meter cube. This product this. So 10 to the power minus 6 kb 1.38 10 to the power minus 23. Temperature 3 Kelvin. So simply it is 15 into 1.38 10 to the power minus 17. 23 minus 6 है ना, और 15 8 जा 120 करी 12, 15 3 जा 45, 45 और 12 57, 20 decimal here, or the answer will come out to be P is equal to V, right, is Snell form 10 to the power minus 16 Newton per meter square or Pascal. People use Pascal as also unit of pressure. To this simple question here, please see. Now I take another question here. I have done many questions regarding gas laws in introductory videos on gas, ideal gas behavior. So please see that all also. Now there is another question here. Actually there is one law, there are two laws, beta. I forgot to tell you. One is Dalton law of partial pressure. Dalton's law of partial pressure. What is this? What is Dalton law of partial pressure? If we have a container of given volume V, and it has so many gases which do not interact with each other, non-reacting gases are filled. Their pressure are P1, P2, P3, P4 and so on. Then according to this law, if many non-reacting gases non-reacting gases are filled in a container and their individual pressures are P1, P2, P3, so on. Then pressure exerted by the mixture of gases is given by P equal to P1 plus P2 plus P3 and so on up to Pn. Actually, these pressure P1, P2, P3 are supposed to be that when they are filled alone, suppose gas 1 filled and apply pressure P1 and alone, and gas 2 filled alone, apply pressure P2, and if they all gases are filled together, even then their pressure will be P1, P2 individual. So this is partial law, Dalton law of partial pressure. One more, actually I forgot to tell you while teaching gas laws. Graham's law of diffusion. Graham's law of diffusion. Now these things are of common sense. They are not mentioned in the syllabus. And these things are supposed to be a matter of common sense. So you have to learn. But nowadays I am observing the students do not try to cram the thing which they have understood. If you have understood, then try to tell it yourself. Very sorry to say, I am teaching individually here also, and students even are not able to tell the definition of rectangle, definition of square, definition of median of triangle, definition of acute angle and obtuse angle, etc. I am very sorry to understand this. बच्चों, बहुत कुछ सीखना होगा तब कभी आप आगे बढ़ पाएंगे. And there is no harm in learning the things. So don't be happy when something is deleted. Just now I will be coming to a very important chapter of waves. That chapter is very important, and I am sorry to say people do not understand what is a wave. और तो क्या बता देंगे वो. वेव का डेफिनेशन भी पता नहीं बच्चों को, क्या even educated people. Once I asked a person well educated what do you understand by wave, so he was confused and said something like this is wave, and he is a very intelligent person. I salute him over his intelligence and knowledge. But some things are there which are not properly taught in the class. They are taught in very much hurry. Generally, when I was in the school, I never taught these things first. I taught simple arm motion and wave motion first, then all these things, because they are important. Anyway, what is Graham's law of diffusion? First of all, try to understand what is diffusion. Basically, so we say movement of particles or molecules. Movements of particles or molecules from higher concentration to lower concentration is called diffusion. One type particle are big in number than other. Then particle often time having higher concentration moves to lower concentration. There was one example here. Here we have two jars. This is filled with CO2 gas. Here it is CO2 filled with hydrogen gas. So CO2 goes down, hydrogen goes up because their gravity. CO2 is heavier than hydrogen. Concentration of CO2 molecule is much higher than here. यहाँ तो है नहीं. So they move. So this motion is because of gravity. So this is not diffusion. This is not diffusion. But if we have system like this, hydrogen jar above and CO2 jar below it, so molecules of CO2 are big in number than here. So being heavier, CO2 goes up and hydrogen being lighter comes down. That is diffusion. I think you will enjoy it. Then what does this law state? According to this law, rate of diffusion is inversely proportional to the density or according to this rate of diffusion of gases कर लिए यहाँ is inversely one density or molecular mass. That is rate of diffusion under root 1 upon rho density or proportional to 1 upon m also, m molecular mass. तो ओके, अगर यहाँ पर नाइट्रोजन होता इंस्टेड ऑफ CO2 तो diffusion rate had been more than this one. This is that thing. I hope you have got my point. Now I come to one important simple question here, but for learner the question which I am telling are difficult. One thing I have noted when I see my viewer, when I tell something very simple, the viewer are more, and when I tell something has a little difficulty, they are not observed by students. I don't know why this is there. We have to learn each and everything. Without basic knowledge, we can't go to the difficult one. Here is a question, please listen to me. A vessel contains two non-reacting gases, neon, monoatomic and hydrogen. neon and oxygen, sorry. It is monoatomic diatomic. The ratio of their partial pressure P1, let it be one gas is 2 or P2 is equal to 3 by 2. The ratio of their partial pressure is, they are filled in a container. A vessel contains nitrogen, neon and helium in a container. Their ratio of partial pressure 3 by 2. Find the ratio of number of molecules and mass density, ratio of mass density of neon and oxygen. The molecular mass actually gives 20.2. You can take it 20 also and 32. So what are you asked? Two things. N1 upon N2, number of molecules. I write here X1 upon X2. Because generally N represents number of moles in gas laws. And then density rho 1 upon rho 2. I think you have got the question. In a vessel, there are two gases, neon and oxygen. Their ratio of partial pressure is this. So we know PV equal to nRT value and the number of moles. And number of moles also can be as X upon capital N RT. X the number of molecules in volume V, or you can write PV equal to X R by N KBT. P hence P1 equal to X upon V, या ऐसे रहने तो कोई बात नहीं. P1 मान लो वॉल्यूम V है X KBT, X1 KBT, टेम्परेचर सेम है. P2V X2 KBT, सॉरी V तो सेम है, एक ही कंटेनर में है. Both gases are filled in this container. Dividing this P1 upon P2 is equal to X1 upon X2. P1 upon P2 3 by 2. So the number of molecules, ratio of number of molecules, X1, X2 are the number of molecules here, is equal to 3 by 2. Simple question. But if a learner is given directly this question without telling, I hope he will or she will not able to do. P1 upon P2. थोड़ा ये नीचे हो गया, मैं यहाँ करता हूँ. P1 upon P2, ये कैंसिल हो जाएंगे X1 upon X2 और P1 upon P2 3 by 2. तो दिस द रेशियो ऑफ मोलिक्यूल्स, यानी कि प्रेशर ऑफ एनी गैस आल्सो प्रोपोर्शनल टू नंबर ऑफ molecules present in the container. Very clear. PV is equal to by nRT. N number of moles in terms of number of molecules, X upon capital N, Navigator number. There is one law in chemistry. सॉरी मैंने नाम भूल गया, अब याद आ रहा है. फिर पूछा रेशियो ऑफ डेंसिटी, इस सेम क्वेश्चन रेशियो ऑफ डेंसिटी. फर्दर पी बी इक्वल टू वी राइट एन आर टी और पी वन बी इक्वल टू एम वन अपॉन कैपिटल एम वन. एम वन इज द मास ऑफ गैस, एम वन इज द मोलिक्यूलर मास, आर टी. P2V, one thing more, sorry. Or you can write P into P1 into V upon M1 is equal to RT upon M1. M1 का Grahm molecular mass. What is this? It is 1 upon density. Rho, sorry, I write rho here. Density rho equal to mass upon volume equal to RT upon M1. So P1 is equal to rho 1 into RT upon M1, and P2 is equal to similarly rho 2 RT upon M2. We are given P1 upon P2. So P1 upon P2 is equal to rho 1 upon rho 2 into M2 upon M1. P1 upon P2 3 by 2. Yes, 3 by 2. Rho 1 upon rho 2. M2 32, it is 20.2. And hence, rho 1 upon rho 2 equal to 3 by 2 into 20.2 upon 32. 6 64. This is the ratio. You can solve it. I hope you will enjoy this question. I will be telling you more question here. Simple, and then I will come to the question which have been asked in competitive exam. If you like, please like my videos. If you have not subscribed, subscribe the video and share the video to your friends.